here. We're going to talk about fractions, and I'm going to quit beating around the bush here. And we don't have any, nobody stepped in, but you never know, someone might. Fractions. And I'd say they are, you use them every day, but fractions are just numbers. And you use numbers every day, right? That's all fractions are. And everybody's scared of them and dealing with them. But you could add them with a calculator using decimals, or you could have a fancy calculator that adds fractions. They have those now. I mean, we're living in the year, what, 2020 almost, 2019. They got these special fancy calculators that do fractions. But we're not going to use those. We're going to do it all the old-fashioned way, because we might need to solve some algebraic problems that involve fractions. And God forbid you don't have a computer algebraic system on your calculator. I have one on my phone, on my cell phone. Yeah, but we're not going to talk about computer algebra systems, but everybody should have one on their cell phone. Right? Because you have one on your cell phone.
Well, I use Google.
Oh, use Wolfram Alpha. It's better than Google. Okay. It's not free, though. It's $1.
Google's free.
It's worth $1.
Okay.
It's worth $1. All you pay is $1, and you get it. Well, you can use the free version, but you get so much more math if you pay $1. It's the best dollar I've ever spent on an app. I'll just say that. So it must be pretty good if because I don't need an app to do math. All right, so fractions. Here we go. Now, when we talk about fractions primarily have two numbers involved.
Okay.
And a fine line between them. Did you see that joke on my Facebook page? Two numbers. And I want to kind of explain these differently. Two numbers. And they are not the top and the bottom. A lot of people call them that because they're smaller, smaller words. But the number on the top is the numerator. And the number on the bottom is the denominator. So now we have words we don't need to use top and bottom. We have numerator and denominator. I am the denominator. And the numerator is how many parts we have, and the denominator is how many parts we split an object into. How many parts we have, how many parts we've split it into. And that's kind of difficult. And right now, for now, and in most cases forever, and as far as fractions go, these are going to be what we call natural numbers, or just counting numbers. They're not decimals or other fractions or pi or nothing like that. Counting numbers. Oh, and I'm falling off the screen. Counting numbers. So like 1/2 means we're taking an object. Right? There's a beautiful square, right? Or is it a rectangle? I think it's a rectangle.
A lovely object.
And then I split it into two parts, okay?
Mm-hmm.
And then I take one of them, and I'm not going to use my good pen to do that. I'm going to use this Gold Star pen. So that's 1/2.
Okay.
Okay. Now, this fraction here, this number is 1/2, is between 0 and 1, right? It's between 0 and 1. Also, what do you notice about the numerator? How can you compare the numerator and the denominator there?
I don't know.
The numerator is smaller than the denominator, yeah?
Will it always be?
No, it will not be. In this case, it is. If I can't spell, denominator. Here we go again. Welcome to I Can't Spell with Josh. Okay, the numerator is smaller than the denominator in this case. This is what we refer to as a proper fraction.
Okay.
2/5, 3/4, 4/5, 1/2, 1/3, 1/4, a quarter, a dime is a tenth, 1/10. Proper fraction. But what happens when we get? What if I have 3/2 of something? So in other words, now all these are the same size, but I have 3 of them. And I'll just pretend those are shaded in perfect. I don't want to waste ink or time drawing. Now I have. Now each box is divided into 2 parts, but I have 1, 2, 3 halves. Right?
Right.
Okay.
Right.
This number is greater than 1. X is this number. We'll just call it X. X is greater than 1. I know we haven't talked about inequalities. We'll just instead of me writing it out, I want to use simple abbreviations, and that was allowed. Phone. Thanks, phone.
What was that?
My phone. Okay. That's a 1-up from Mario. You didn't know that, did you? Learn something every day. Okay. This is bigger than 1. All right. It's also, if this is 1.5, we could say that it's 1.5. Right?
Yes.
Okay. That's bigger than 1. 3/2 is 1.5, which is bigger than 1.
Mm-hmm.
What do you know? How do you compare the numerator and the denominator?
I don't know what you're meaning by that
The
question.
numerator, compare them. One is bigger than the other. The numerator is bigger. There's only one way to compare numbers, and that's size.
Okay.
Numerator is bigger than the denominator. Or, actually, bigger or equal to. That's how many halves?
It's 3 halves.
Right here.
Well, that's 2 halves.
2 halves. 2 halves is 1. Okay?
Right.
Right. 3 halves. This is x is greater than or equal to 1. Yeah. It can be equal to.
Mm-hmm.
Okay. This is an improper fraction. If the numerator is bigger than the denominator, which in this case 3 halves is improper fraction.
Got it.
5. Pick a number and make that an improper fraction.
3.
3.
5.
Very good. Thank you. I'm just kidding. Improper fraction. The numerator. You could have put 5 too. 5 would have been good too. These are improper fractions. Now, improper fractions can be written as mixed numbers, where it shows the number of whole parts and a proper fraction, like this, 1 and 1/2. Mixed number is the whole parts, and I'm off the screen and you're not telling me, a proper fraction. Are you really watching this?
I am.
I don't know. Fraction. Okay. All right, so we're going to convert, the next part, we're going to convert back and forth between mixed numbers and improper fractions. Okay, that's the first topic.
Okay.
We're not going to worry about reducing and simplifying and adding yet. We're going to do that in a minute. But first, we're going to convert between mixed numbers and... Okay, so which one are we going to do first? Let's convert a mixed number, because this one's the easier one. Convert a mixed number to an improper fraction. Okay. So, let's use our example of 3/2. We're going to use the proper, right? And we already know the answer. 3/2 is what?
1 and 1/2.
1.5. Okay. All right. So, if this symbol actually, this is a good way to remember this. Oh, so we're going to convert a mixed number to an improper fraction. So we're going to start with this and then end up with that. And I did it backwards. So we're going to start with a mixed number. Start here and go this way.
Okay.
Okay. All right. I hope. That's the goal. Okay. So I'm going to write this as whole number, numerator, and denominator. Okay?
Okay.
Okay. The formula here is we take the denominator and multiply it by the whole number. So the denominator multiplied by the whole number. And then we add the numerator. And the denominator will stay the same. So that's our little formula for that. Not too bad. Yeah?
Looks manageable.
Looks manageable. But, I mean, it looks tricky, but the denominator is going to always be the same.
Right.
Right. If it's reduced. But, you know, from when you start from here and go to here, the denominator should be the same. If it's reduced, which we're going to talk about in just a minute, it should be easier math. That's why we reduce fractions, so we don't have to deal with such big numbers. Okay, so let's look at our example here. If we take the denominator and multiply it by the whole number, we get 2, and 2 plus 1 is 3. Let's do another example. How about 4 and 3/8?
Okay.
Okay, so we take the denominator, which is 8, and we multiply it by the whole number, which is 4, and then we add 3, and the denominator will stay the same. Okay, so 8 times 4 is 32, plus 3 over 8, and then 32 and 3 is 35 over 8. Okay. Not too bad. I don't think we need to do another one. I don't see nobody's in the chat to argue with me, so hopefully that's enough.
Yeah, no,
I haven't really had some problems with this. Let's go backwards. Okay, so most of the time when you reverse a process, you do the opposite.
Right.
Opposite operation. So you think about it, the denominator is going to stay the same. That you can't do an opposite of that. There's no reason to make it different. What would it be if it was different? So the denominator is going to stay the same. We're going to go from improper fraction to division. Okay, so we're going to have a numerator over divisor, and it's going to equal what? Okay. Well, the opposite of multiply is divide, so we're going to divide like this. And I'm going to put it over here.
Okay.
We're going to divide the denominator into the numerator. And then what we get from that is a quotient, right?
Mm-hmm.
And a remainder. Right? We're going to have a remainder. Unless the remainder is 0, and then all you have is the quotient. That would be just a whole number. Okay, so we're going to take this and put it in our formula here. So it's going to be improper fraction. No, mixed number would be the quotient, would be the whole number. And the remainder is going to be the numerator in the new fraction. And the denominator is going to stay the same. Just like this. And let's use 35 over 8 as an example. Okay. So we take 8 and we go into 35. 8 goes into 35 4 times. And 4 times 8 is 32. Get the remainder of 3. So, as a mixed number, it is 4 and 3/8. And look, it's what we got there too. See what I did?
Imagine that.
Okay, so that means we did it right here. You can always check your work that way. Okay. Okay. I think we have a good grasp on that. I don't think we need to do any more examples. What do you think?
I think we're all set with that one.
Okay. The first topic is good. There's